Hello everyone. In this video, we will try to study clocked RS flip-flop using NAND gate and NOR gate. So here we can see the circuit diagram for a clocked RS flip-flop using NOR gate and clocked RS flip-flop using NAND gate. So for this experiment, we require two NOR gate, two AND gate, a pulse generator, a 3-volt DC power supply, two switches, and two bulb and also a CRO for the timing diagram. And for realizing the clock RS flip-flop using NAND gate, we required 4 NAND gate, a clock pulse generator, 2 key, a 3-volt DC power supply, 2 bulbs, and a 4-channel oscilloscope. So before starting this connection, we will explore about the theory. So basically in RS flip-flop, we can't operate the RS flip-flop with a clock or with a timing device. That's why it will give a asynchronous output. So in order to get a synchronous output means the output is controlled with a clock pulse or with a timing device, we make clocked RS flip-flop. We can make a clocked RS flip-flop just by adding a NAND gate to the inputs of the RS flip-flop, and both the NAND gates are connected together with a clock pulse. So when clock pulse are connected with the NAND gate, then in this case, if we give the input of the clock pulse as 0, then in spite of changing the inputs of flip-flop, that is the changing the values of R and S, we will not get any change in the output. But as soon as we will set our clock pulse to the 1, then in this case, if we will change the input, then output will also get changed. So for R0 and S1, we will get output as a high, that is the set state of flip-flop, and for R as 1 and S as 0, we will get output as a 0, that is the reset state of a flip-flop. But here also the problem arises with the 1-1 case where the undefined output is obtained. So this is the timing diagram of RS flip-flop, what we have to realize after the connection. So quickly we will start the connection and make the clocked RS flip-flop using our components. So let's start with the connection. So here we can see this is the connection of our RS flip-flop what we have made in a previous video. Now we will make the RS flip-flop in clocked flip-flop. So for this we will take two AND gate and we will connect input of AND gate with the one of the signals, that is with the key S3, and input of second AND gate is connected with the key S4, which are connected to the positive terminal of DC power supply. Second terminal of the both NAND gate are connected together and they are connected with a clock pulse generator. Now the output of first the one of the input of NOR gate, that is the basically the R signal or R terminal of our flip-flop, and output of the second AND gate is connected to the S terminal of the flip-flop. So now we have made the connection of clocked RS flip-flop. So now very quickly we will verify our truth table, that is as soon as we will start this connection. So initially we don't know what is the initial state of the flip-flop. So just for convenience we will take initial state of the flip-flop will be S, that is the set mode. So for this, for 0 clock pulse, if we will close the first switch or second switch, there is no change in the output observed because the clock pulse is set to 0. What is our first case? Now as soon as we will set the clock pulse to the 1, and then if we will apply the signal from R or S terminal, it will set the flip-flop to the set and reset mode. So as soon as we will close the key S3, we will apply signal through R terminal of flip-flop, and then this set the flip-flop into reset mode, that is the output of Q will be 0 and that of Q dash will be 1. Now as soon as we will open the switch, it will remain in the same state as it stores our data. Now as soon as we apply the input from the second terminal, that is the switch S4, then the signal will flow through the S terminal of the flip-flop and it will set the flip-flop to the set state, that is the Q will become 1 and that of Q dash become 0. So this is the simple verification of clocked RS flip-flop. Now we will analyze the timing diagram with the help of oscilloscope. So for that we will connect the different terminals. So first of all we will connect the terminal A with the R and B channel of the oscilloscope is connected with the S terminal of the flip-flop. Now the channel C is connected to the Q output and channel D is connected with the QR state. So this is the basic connection. Now as soon as we will start the power supply, we will see the waves are started forming in our oscilloscope. So basically here the red line representing the R signal, as white line representing S signal, green is representing the Q state, and blue is representing Q dash state. So initially we will set the flip-flop to the set mode by closing the switch S4. So here we can see that the output of green goes high and that of the output of blue signal goes low. So now we will change our clock pulse to the 0. And now in this case, if we will close key A or open key A, or close key S4 or open key S4, that is if we apply the signal from the R terminal or S terminal, there is no change in the output observed as clock pulse is 0. Now as soon as we will set the clock pulse to the 1, and in this case if we will close the switch S3, that is we apply the signal through the R terminal of the flip-flop, then the output of Q goes low and that of Q dash goes high, that is the flip-flop will go into reset state. Now as soon as we will open the switch S3, it will remain in the same state as flip-flop stores our data. Now as soon as we will close switch S4, the output of Q goes high and that of Q dash goes low, that is the flip-flop goes into set state. And again if we will open the switch S4, it will remain in the same state, that is the state of flip-flop do not changes. Now again if we will close the switch S3, it will goes to reset state, and if we will close the switch S4, it will goes to the set state. So this is the timing diagram of clocked RS flip-flop in which we have controlled the output with the clock pulse and by changing the input signals. So this is the timing diagram for our clocked RS flip-flop using NOR gate. Now we will try to make clocked RS flip-flop with the help of NAND gate. So now we will start the connection. So making RS clock flip-flop using NAND gate, we required 4 NAND gate. So first of all, we will see that this is the basic circuit diagram or basic the wiring diagram for our RS flip-flop using NAND gate. Now we will convert this flip-flop into clocked RS flip-flop. So for that, we will connect the switch S2 and S1 with the positive terminal of DC power source, and the second other terminal of the switch is connected to the one of the input of first NAND gate, and key S2 is connected to the one of the input of second NAND gate. Now the other two input terminal of NAND gate 1 and 2 are connected together with a clock pulse, and the output of the NAND gate 1 is connected to the input terminal of third NAND gate, and output of second NAND gate is connected to the input terminal of fourth NAND gate. So in this way we will make a RS flip-flop into a clocked RS flip-flop. Now we will start the power supply and verify our truth table. Initially we can't determine the initial state of RS flip-flop, basically clocked RS flip-flop. So just for simplicity, we will take the initial state of the we set. Now in this case, if we will set the clock pulse to 0, and now if we will apply the input signal, then output of the flip-flop won't get affected. Hence for the 0 clock pulse there is no change in output. Now again if we will set the clock pulse to the 1, then in this case if we will close the switch S1, that is apply the signal from the S, then this will set the flip-flop to the set mode, that is the output Q will goes high and that of Q dash go low. Now as soon as we will close the switch S2, we will set the flip-flop to the reset mode, that is the output of Q goes low and that of Q dash goes high. Now we will verify this truth table, or basically we will make a timing diagram of clocked RS flip-flop using oscilloscope. So for that we will connect the oscilloscope. So for that we will connect the channel A of the oscilloscope to the S terminal, and channel B of the oscilloscope is connected to the R terminal of the flip-flop. Channel C is connected to the Q terminal or Q state of the flip-flop, and that of channel D is connected to the Q dash state of flip-flop. Now we will switch on the power supply and see the timing diagram. So as soon as we will switch on the power supply, we will see that some waves are start forming in. So initially we will take the reset state of the flip-flop. Now if clock pulse goes to 0, then in this case if we will close the switch S1 or open the switch S1 or close the switch S2 or open it, there is no change in the output observed. Now as soon as we will set the clock pulse to the 1, in this case if we will close the switch S1, then the flip output of flip-flop goes to set mode, that is we will get Q at higher logic and that of Q bar at a lower logic. Now as soon as we will open the switch, there will no change in the output. Now as soon as we will close the switch S2, the flip output of the flip-flop, that is the Q dash, goes to high and Q goes to low, that is the flip-flop goes to reset state. Now again if we will close the switch S1, it will goes to set state as green pulse goes high and orange goes down, and as soon as we will close switch S2, it goes to reset state. So see, this is the basic timing diagram for the clocked RS flip-flop. Now if we will set the clock pulse to the 0, then in spite of changing the input signals, we will not get any change in the output. So this is the timing diagram for our clocked RS flip-flop using NAND gate. Thank you.